Me. All right, we are recording. This is on your desk. This lesson reviews multiplying matrices. We have also found inverses and determinants by hand. We're going to talk about using a determinant to find an inverse, and we're going to talk about finding the inverse on your calculator and then using an inverse to solve a system. We solved systems using RREF last week. Does that sound familiar? Okay. First thing we want to do is just review a simple multiplication. Can we multiply these? Yes. What size are these two matrices? Okay. So this is a 2 by 2 times a 2 by 2. So our resulting matrix will be a 2 by 2. Okay, do this one by hand. You will have to do one by hand with a variable in it on the test next week. For today, the ones that you have to do, I'm going to show you how to do them on the calculator eventually, but let's review by hand. Row times column gives you the first row, first column. So it's 2 times -1 plus 4 times 0. Everybody see where I got that? Okay. Same row, second column would be 2 times 5 plus 4 times -2. All right, anybody try the next one? Tell me what the calculation is. Good job. And the last one is the bottom row times the second column, and that goes in the bottom row, second column. -3 times 5 plus -1 times -2. All right, anybody got the arithmetic done for us? -12, is that right? 2, -13. -13? Sorry, that's really tiny. Can you read that? All right. Matrix multiplication is not commutative, okay? It says find AB and BA if possible. If we switch the order and we write this one first, and then we write A, can we still do this? Yeah. Still 2 by 2 times a 2 by 2, okay? But it's not going to give us the same answer. This row times this column, let's see if we can do this without quite so much writing, would be -2 plus -15. Okay, or -17. Did anybody else get that? Okay. This row times the second column will be -4 plus -5 or -9. This row times the first column would be 0 plus 6 or 6. And second row times second column, 4 times 0 is 0, plus -2 times -1 is 2. All right, that's what I got. Anybody else? Okay. Those were by hand, and clearly A times B and B times A are not the same thing. Everybody all right? All right, can we do A times B here? A is a 2 by 2. B is a 2 rows, 3 columns. Everybody okay? So can we do this? Yes. Because these are the same, we can multiply and get a 2 by 3. will we be able to do B times A? When we switch it around, we'll have a 2 by 3 times a 2 by 2. Is that okay? No, because these aren't the same, we won't be able to do this. Okay, B times A is not going to be possible. All right, let's see if we can do this in our heads. This row times each of these columns. So the first one is 2 plus negative 9. Anybody got that? 2 plus negative 9, negative 7. What about the next one? Negative 4 plus negative 3. Another negative 7. Like the next one, it's got a 0. Just 6, yep. All right, now next row times each of these. Positive 6 plus negative 6 is 0. Negative 12 plus negative 2 is negative 14. How did I do? And 0 plus 4. Okay. I'm going to show you how to do this on the calculator. Okay? I'm not going to use this problem just to save us a little time. We're going to go right to the next problem. Do it on the calculator. All right. The next, and this is what it's going to look like when we do it on the calculator. In the home screen, we're going to have two separate matrices saved, and they're going to say A times B. All right, this problem, don't type anything yet, just pay attention up here. What size matrix is this right here? It is a 3 by 3, okay? It says Holly, Joelle, and Luisa are competitive skaters. Their routines are judged on skating skill, choreography, and interpretation. There's two different systems, System A and System B, that weight their scores differently. Okay, this is a 3 by 3. What does the first 3 represent? The rows are what? Yes, the 3 different skaters. Everybody with me here? Because this is really important that you understand what the labels on your answer matrix are. Those are the skaters. These are their scores in each criteria, so I'm going to say this is their score, okay? Now when I move over to this, what size is this one? This is 3 rows and 2 columns. Everybody okay? The 3 represents their 3 different criteria or scores, right? The 2 represents whether we're using System A or B. Everybody okay? So when I multiply those together, can I multiply them first of all? Those 3's are the same, so yes, my answer matrix will be a 3 by 2. What are the 3 going to represent though? The skaters. So we're going to have Holly, Joelle, and Luisa. And across the top, the 2 will represent their score if we used A or B. All right, we're going to put all this in a matrix A, which is going to be a 3 by 3. Then we're going to go in and edit and put this in matrix B. We are going to want to use decimals. Okay, take away the percent sign, then you got to move the decimal. And then we're going to say matrix A times matrix B on our home screen. All right, here we go. Matrix, edit, A as a 3 by 3. Please be doing all this today. Right, then you want to quit and go back into matrix and edit, go all the way to right, and go down to matrix B. And what size did we decide that one was? 3 by 2. Yes. I'm not sure I have them right. Does that say 0.3 right there? It does, okay. Yeah, they're tiny. Okay. Then in the home screen, so you got to quit again. You just go back and you put the name of matrix A, hit the multiplication button, go back into matrix and go down to B. So on your home screen, it should say the name of matrix A times the name of matrix B. Okay, got some crazy decimals. So 3.8, 4.2, 3.43, and 4.2, 3.8. Yes?
So we could just do this, like, use our hands to put the calculator, right?
Yes, if you did row times column, yep. Okay, so which system, it says which system favors which skater. So Holly does better under system B. Okay, she would actually win, right? If we used B, she'd have 4.2. Joelle does better under system A, but no matter whether we use A or B, she finishes in third, right? Louisa would win if we use system A. Everybody get that? Okay. So there's a real application of where you can multiply things to figure out which does better for which person. If there was a system C, yet another reason why it would be easier to do it as a matrix on your calculator. What Philip is saying is because it's only two things, he found it faster to just do it by hand, because it does take a while to type it in. All right. Identity matrix. An identity matrix is when you have ones on the diagonal from left to right, and everything else is a 0. Identity matrix is also always a square matrix. Just to review, we used this concept in an extended matrix when we used RREF. If this had been an XYZ set of equations, this would have meant x equals 7, y equals -3, and z equals 2. Remember that? Okay. This part was an identity matrix. So your notes say that an identity matrix has to be a square matrix, n by n. The ones are on the diagonal from upper left to lower right. All the other elements are zeros. The identity matrix is just called I. And here's the important part, guys. If you take two matrices, A times B, and then B times A, and each time you get an identity matrix, then they are said to be inverses of each other. All right, so when you have two square matrices and you multiply them together in either order and get an identity matrix, then A and B are said to be inverses of each other. And to write that, you use this. This means inverse of A. Notice where that button is on your calculator. It's the same button that matrix is, right? Is that little x to the -1? Okay, it's because you use that button when you're using matrices. It's going to be the inverse button. All right, when a matrix has an inverse, it's called inversible. And we talked about determinants last week. The determinant is a single value found by taking this diagonal, the product of that diagonal minus the product of that diagonal. Remember that? Okay. As long as the determinant is not 0, your matrix will have an inverse. So it's a quick, easy test to find out if something has an inverse. But if it says show that something has an